Consider the problem. Show integral over 0 to infinity sin x by x dx equal to pi by 2. So we want to show that integral over 0 to infinity sin x by x dx equal to pi by 2. Now consider the function f of z equal to e raised to I z by z has a simple pole at z equal to 0, because the function limit z tends to infinity, z tends to 0, mod f of z equal to infinity, and limit z tends to 0, z minus 0 into z e raised to I z by z. Then its limit value is 0. Then z e raised to I z by z has a removable singularity at z equal to 0. Now z equal to 0 is a pole of f, and z f of z has a removable singularity at z equal to 0. If f has a pole at z equal to a, and m is the smallest integer, such that f of z equal to f of z into z minus a whole raised to m has a removable singularity at z equal to a, then f has a pole of order m at z equal to a. Then using this result, set f has a pole of order 1 at z equal to 0, that is f has a simple pole at z equal to 0. uh, if 0 less than r less than capital R, here a graph is depicted in here. Here the let gamma be the closed curve, and f is analytic on and inside gamma, and hence it follows from Cauchy's theorem that integral over gamma f equal to 0. Here the graph z equal to 0 lies outside gamma, and gamma capital R are the semicircle from capital R to minus R, and gamma small r and another semicircle from minus small r to small r, positive small r. Now breaking gamma into pieces, then it becomes 0 equal to integral over small r to capital R e raised to ix by x dx plus integral over gamma capital R e raised to iz by z dz plus integral over minus capital R to small r e raised to ix by x dx plus integral over gamma small r e raised to iz by z dz. Now consider integral over small r to capital R sin x by x dx. This can be written as integral over small r to capital R e raised to ix minus e raised to minus ix by 2I into 1 by x dx. Then take 1 by 2I outside, then 1 by 2I r to integral over r small r to r e raised to ix minus e raised to minus ix by x dx. Now split this integral, then 1 by 2I integral over small r to capital R e raised to ix by x dx minus 1 by 2I integral over small r to capital R e raised to ix by x dx. This can be written as 1 by 2i integral over r to r e raised to ix by x dx plus 1 by 2i integral over minus r capital R to minus small r e raised to ix by dx e raised to ix by x dx. Now, the parameterization of gamma capital R is z equal to capital R raised to I theta, where theta 0 less than or equal to theta less than or equal to pi. And using this, we have the line integral modulus of uh, integral over gamma capital R e raised to I z by z equal to integral over 0 to pi modulus of integral over 0 to pi e raised to I r e I theta divided by r e raised to I theta d of r e I theta. That is, we substitute the value of z equal to r I theta. Then this can be written as e raised to I r e I theta divided by e r r e I theta into I r e I theta d theta. Now this can be written as modulus of I into integral over 0 to pi exponential of I r I theta d theta. This is which can be less than or equal to 0 to infinity modulus of exponential of I r I theta modulus d theta. That is integral over 0 to pi modulus of exponential of I r e I theta d theta. Put it equation number 1. Then r I r e raised to I theta can be written as, now substitute the e raised to I theta, I r cos theta plus I sin theta. This can be written as r into minus sin theta plus I cos theta. Hence, exponential I r I theta equal to exponential of r minus sin theta plus I cos theta. That is, this can be written as exponential of minus r sin theta into exponential of I r cos theta. So that modulus of exponential of I r I theta equal to modulus of exponential minus r sin theta into exponential of I r cos theta. Here this term is must be greater than or equal to 0, and this term equal to 1. So then modulus is equal to modulus of this term is equal to exponential of minus r sin theta. Hence the modulus of integral over gamma capital R e raised to I z by z equal to integral over 0 to pi exponential of minus r sin theta d theta. Put it equation number 2. Now choose delta greater than 0 sufficiently small, then integral over 0 to pi exponential of e raised exponential of minus r sin theta d theta can be written as split into integral over 0 to delta delta to x pi minus delta pi minus delta to pi. that is integral over 0 to pi exponential of minus r sin theta d theta equal to integral over 0 to delta exponential of minus r sin theta d theta plus delta integral over delta to x pi minus delta exponential of minus r sin theta d theta plus integral over pi minus delta pi exponential of minus r sin theta d theta. For 0 less than or equal to theta less than or equal to delta, then sin 0 less than or equal to sin theta less than or equal to sin delta. And since the real valued function e raised to minus y is strictly decreasing, it follow for that 0 less than or equal to theta less than or equal to delta, then exponential of minus r sin theta is less than or equal to exponential of minus r sin theta, that is e raised to 0 is equal to 1. By a similar argument we can see that for pi minus delta less than or equal to theta less than or equal to pi, then exponential of minus r sin theta less than or equal to exponential of minus r sin theta sin pi, that is exponential of 0 equal to 1. Then uh, this term and this term can be written as integral over sorry, this term, not this term, this term, integral over 0 to delta exponential of minus r sin theta d theta less than or equal to integral over 0 to delta d theta equal to delta, and integral over pi minus delta to pi exponential of minus r sin theta d theta, which is less than or equal to integral over pi minus delta to delta d theta, that is delta. The real valued function f equal to f equal to exponential of r sin theta is continuous on delta pi minus delta, then it is only critical point in the interval closed interval delta pi minus delta is delta equal to pi by 2, because the interval delta pi minus delta, then d by d theta of exponential of minus r sin theta equal to uh, exponential of minus r sin theta d theta d by d theta of minus r sin theta, that is exponential of minus r sin theta into minus r cos theta, then this term is not equal to 0, uh, this equal to 0, then theta equal to pi by 2. The values of f at the critical point pi by 2 and the end points delta and minus pi minus delta are f of pi by 2 equal to exponential of minus r sin pi by 2, f of delta equal to exponential of minus r sin delta, and f of pi minus delta equal to exponential of minus r sin pi minus delta. This is equal to exponential of minus r sin delta. So since sin delta is less than or equal to sin pi by 2, uh, from from the figure, and the exponential of minus y is strictly decreasing real valued function, it follows that the above values exponential of minus r sin delta is maximum. That is the largest possible value of exponential minus r sin theta with delta less than or equal to theta less than or equal to pi minus delta is exponential of minus r sine delta. Then integral over uh, delta to pi minus delta exponential of minus r sine theta d theta less than or equal to exponential of minus r sine delta integral over delta to pi minus delta d theta equal to exponential of minus r sine delta pi minus delta which is less than or equal to pi exponential of minus r sine theta sine delta. Then this equation can be written as modulus of integral over gamma cap over capital R e raised to I z by z dz less than or equal to 2 delta plus pi exponential of minus r sine theta sine delta. Since r tends to infinity, exponential of minus r sine theta equal to 0. For any eta greater than 0, there is a r naught such that exponential of minus r sine delta equal to modulus of exponential of minus r sine delta minus 0 which is less than eta for all r greater than or r greater than r naught. Now if epsilon greater than 0 is given, choosing delta less than epsilon by 3, and there is an r naught such that exponential of minus r sine delta less than exponential less than or equal exponential of minus r sine delta less than epsilon by 3 for all r greater than r naught. Thus integral over modulus integral over gamma r e raised to I z by z dz less than 2 epsilon by 3 plus epsilon by 3 which is equal to epsilon. That is, we have shown that for every epsilon greater than 0 there is r naught such that the above inequality hold. So by the definition of limit at infinity, limit r tends to infinity, integral over gamma r e raised to I z by dz equal to 0. E raised to I z minus 1 z is not defined at z equal to 0 and is the only point at which z e raised to I z minus 1 by z is not analytic. Now thus z equal to 0 is a removable singular point. Also limit z tends to 0, z minus 0 e raised to I z minus 1 by z equal to limit z tends to 0 e raised to I z minus 1 equal to 0. Thus e raised to I z minus 1 by z has a removable singularity at z equal to 0. Hence there is an analytic function g on c such that f of z equal to g of z when z not equal to 0. In particular, g is continuous and is bounded on any compact set. In particular, g is bounded on B closure 0 1. Hence, there is m greater than 0 such that mod g of z less than or equal to m for z belongs to B of B closure 0 1 and hence modulus of e raised to I z minus 1 by z less than or equal to m for 0 less than mod z less than or equal to 1. Now the parameterization of z equal to z equal to gamma e I raised to minus I theta of gamma small r when 0 less than or equal to r less than or when 0 less than r less than 1, then each point on set on gamma small r is included in the analysis 0 less than mod z less than or equal to 1, so that modulus of integral over gamma r e raised to I z minus 1 by z dz, which is less than or equal to integral over r modulus of e raised to I z minus 1 by z modulus of dz, then which is less than or equal to this term is less than or equal to m, then less than or equal to m integral over gamma over gamma r mod dz, that is m into integral over pi to 2 pi mod d of r e I theta, that is m r, here r is constant, m r integral over pi to 2 pi mod e raised to I theta d theta, that is m r into integral over pi to 2 pi d theta equal to m r pi. Then the limit r tends to small r tends to 0, integral over gamma r e raised to I z minus 1 z dz equal to 0. But gamma integral over gamma r 1 by z dz equal to integral over pi to 2 pi 1 by r e raised to I minus I theta d of r e raised to minus I theta equal to minus I 0 to pi d theta, which is equal to minus pi I for each r. Then equation 6, this becomes minus pi I equal to limit r tends to 0, integral over gamma smaller e raised to I z by z dz, then this equation becomes number star becomes 0 equal to integral over 0 to infinity e raised to ix by x dx minus pi I plus integral minus infinity to 0 e raised to ix by x dx, that is 0 equal to integral over 0 to infinity e raised to ix by x dx minus pi I integral over 0 to infinity e raised to ix by x dx, that is integral over 0 to infinity e raised to ix minus e raised to minus ix by x dx equal to pi I, that is integral over 0 to infinity e raised to ix minus e raised to minus ix by 2xi dx equal to pi by 2, that is divide 1 by 2 in both side. So that is integral over 0 to infinity sin x by x dx equal to pi by 2, hence the proof.